Hi, good morning. This lab is very similar to to the previous lab. This is lab 8, lab 7, lab 8 maybe. Concave and convex lenses, and is going to be very similar to what we did last time. Let me share with you here what is gonna be in this lab. Of course, again, this lab is going to be a formal lab report, which means you are going to submit 2 files. One of them is the the Excel sheet, and the other one is the formal lab report. You need to stick with my number here, 4.3, for your lenses that you are going to use. We're going to use again O physics, and also you need to use the numbers that I gave here for you for the object distance. You will record V for that. Here this is a calculation, and then you're going to calculate the magnification, and then you're gonna tell me if the image it is real or virtual, erect or inverted, and the size. This part here should be under calculation thing. Also, you will create another table in your calculation section where you are going to have 1 over U, 1 over V M. You're going to graph 1 over V divided by 1 over V versus 1 over U. And of course, like we did last time, it's exactly the same. Derive a relationship to show you how you are going to calculate the focal length of the lens. And calculate the percent difference between the theoretical value that we put and also the experimental value. Verify your results here by graphing gray diagrams for the third and the third case from the table above. Then you're gonna come to this one here. You are going to show the ray diagrams like I did show you in the class for this one and this one. We are going to repeat the same thing for the double concave, and also we are going to verify the cases the same way. Okay, let me show you here. Of course, yeah, okay, let's go to the simulation. Oh, what I did, why it's not taking me? Okay, then I don't know what's wrong. Okay, then I will here have it we're going to start with double convex like this one. Let me assume I'm gonna use for my focal length 2, and then here you can change the distance of the object, and you can actually find the different cases. Now here is showing you the focal. I don't want you to read it from here. I want you to make it like kind of approximate here so that you will be able to just use measurements. Okay, and of course here is giving you the values. Okay, for the object. Okay, and just you can work with this in a way that you survey all the values that I gave you. All right, now let's I will share also with you my Excel file here. Okay, this is my data for my U, my V, my magnification, 1 over U here, and 1 over V. Of course, they will not appear in the same I will say graph, not in the same, I mean section. V and U, they're gonna be under the data, and the rest is gonna be under the calculation. Okay, and here I think here I did write 1 over U. It should be 1 over V. Okay, and then this is the convex lens, and I want you to also calculate what is really the, put the equation of the graph, use that to calculate what is really the focal length of this lens. I did repeat that here for my numbers, and I will have that in here. Okay, and again we are going to use this, not did I say the slope, the equation to calculate the what is called the focal length of that lens. Okay, this is really very similar to what we did in the first one, okay, in the previous lab. Thank you.